Hello viewers, welcome to my channel and thank you for watching the videos. In this video, CSAT topic probability and statistics and permutation and combinations will be discussed, formulae about and a few questions based on that. Probability and statistics and permutation and combinations. Probability theory was originated by games of chance. So games of chance कौन कौन से एग्जाम्पल हम ले सकते हैं? Basically in real life all problems are games of chance, but in classroom exercise, but very well known examples are flipping of coin or coins. We can flip two or more coins together, playing cards, rolling dice. So here two possibilities are there, head and tail. Here 52 cards are there, and in particular 4 types are there. Rolling dice, it's a cube, a small cube, which we use for play, and sides have been marked 1, 2, 3, 4, 5, 6. So there are 6 possibilities here. Here 52. In simple example, we may make many combinations out of these. Nowadays, mathematical models of chance processes called random experiments. Mathematical models of chance processes called random experiments. So we take such an experiment and we observe a random variable x, that is a function whose values in a trial, x means whose values in a trial occur by chance. So for example, we have done these. So values are occurring by chance. And we talk about probability distribution. A probability distribution, or sometimes we call it distribution, shows the probabilities of event in an experiment. The quantity that we observe in an experiment will be denoted by x, and we call this x as a random variable or stochastic variable. So there are discrete random variable and distribution, and continuous random variable and distribution. So as I said, probability distribution shows the probabilities of events in an experiment. So probability distribution, when we are doing the experiment for long run, then we can have this probability distribution. For single experiment, we won't be having a distribution. So for example, we say here that when we have 6 faces for the dice, then we have 1 by 6 probability. Here 1 by 2 if one trial is there, only one experiment is there, and here 1 upon 52 if we have drawn one card. There may be many other possibilities and cases where we can do this. Many combinations of the throws. Suppose we are throwing 4 dice simultaneously, or we are throwing 10 coins simultaneously, or we are taking cards, 10 cards out of the pack without replacement or with replacement. So there may be many cases. Now when we talk about distribution, we take one example that X is this and say Y. So we are either repeating the experiment many times, or we are having some data which we have collected for many people or experiments or cities or students. So let's say there are 5 students, 1 2 3 4 5, and they got marks, total marks got 10, 15, 25, 30 and 35. So we have arranged this data in increasing order. It may be not in this order. We have rearranged that. We mark the student 1 who got minimum marks and mark the student 5 who got maximum marks. So we can draw this by histogram. This is just for histogram. We are taking this data that we can mark, take some interval 0.5 on this side, 0.5 on this side, and can mark here 1, and we can draw that it got 5, 10, 15, 20, 25, 30, 35. So this one is got 10 marks, then 2 got 15. So we can mark on x-axis 3, 4 and 5. So 2 got 15. So we got bar. 3 got 25. And then 4 got 30. And last 5th got 35. So these are the histograms where marks in increasing order. So we generally have data in this form in the examination. Now few terms and measurements which we use very frequently. As data may be that only marks have been given for students, say 10, 15, 25, 30, 35, this has been given. We can mark them 1, 2, 3, 4, 5. Or data may be in interval. In interval means 0 to 10, 5 students are there, and these are the marks. Earlier these were the marks. Now interval is there, 10 to 20, say 4 students are there, 20 to 30, 3 students are there, 30 to 40, 2 students are there. So total number of students are 14 students. So between 0 to 10, 5 students got marked, between 20 to 24, and between 20 to 30, 3, and between 30 to 42. So total number of students. So this may we have some distribution of data. So first we have to find out range measurement. for this one, range x maximum minus x minimum. So range of these marks will be 35 minus 10, so 25. Then we have median. Mean will be, when we are taking average of that median is middle value or when data points are odd, means numbers of data are odd, then middle value, or average of two middle values when data points are even. And median is middle quartile also. We write QM, upper quartile, lower quartile. Means suppose this 0 to 100 data is there, so we have divided data into 4 parts. This is QM, which is 50th value, then this is 25th value, so QL, and this will be 75th value, QU, upper quartile. So we divide this data in this. So range also we can find out. Range of quartiles we can call interquartile range is equal to QU minus QL. So QU is, as we said, median is middle quartile, and we said median is middle value when data points are odd, and when data points are even, then median is average of the two middle values. So QU is the middle most value on the average of two middlemost values middlemost value like we did in the case of median, जबकि डेटा जो है odd numbers हैं, and here when even numbers of data in the data above the median, and we can write IQR, and QL is same definition, only thing here will change, in place of above this will be below, rest is same, is the middlemost value on the average or the average of two middlemost values QU is the middlemost value when data is odd, or the average of two middlemost values in the data above the median. So this point is important, above the median, and this is for when data is even, middlemost, two middlemost values. and QL will be same but below the median, so interquartile range. So this is one of the measure. So how to find one example? Suppose we have got the data points 10, 15, 12, 13, 11, 14, then 9, 8, 6, 7, 5, 4, 2, 3 and 1. So 15 values are there. First thing, we will write them in ascending order. 1, 2 for median, and QL, QM, QU. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. We have written in ascending orders. So these are odd number of points. So middle value will be this one. 7 values on this side, 7 values on this side. So median is this, and this is QM also. So QM is 8. Now we have to find out QU and QL. So QU will be, now 7 values are there, odd number. So we will take 3 on this side, 3 on this side, and the middle value will be there. So we have 9, 10, 11, 13, 14, so 12 is the value, and QL will be on this side, on left side. So 4 will be the value, because 1, 2, 3 on this side, and then 4 and 5, 6, 7 on this side. So this is for, if we want to find out IQR, it will be 12 minus 4, which is 8. Suppose we extend this data, instead of 15 we take 1 to 30, 1 to 15 we take 1 to 30. Now this is even number. Even number means we have QM average of 2 middle values. And then it will be 15 plus 16 by 2, which is 31 by 2, 15.5 QM. And for QU we have values 16 to 30. इस केस में हम इसे इस तरह समझ सकते हैं कि ये 15 वैल्यूज हैं. So mid of this means 7 values on this side and 7 values of this side. So this will be 23rd, 23rd value also, which is 23. And similarly for QL 1 to 15, because we have divided data in 1, 15 and 30. So this and this is QM. Here this is 23 QU, and this is QL, which is 7 on this side, because odd number, middle is 8th, so 8th value, and which is equal to 8. If we mark 1, 2, 3, 4 up to 30 as x1, x2, x3, x30, then we can write QM is equal to 1 by 2 x15 plus x16. QU is equal to x23 and QL is equal to x8. QL is equal to 8. QL is equal to X8. So we can say interquartile range is equal to 23 minus 8, which is equal to 15. And range is 30 minus 1, which is 29. अब मीन की बात करते हैं. अगर हमारे पास सैम्पलिंग में या एक्सपेरिमेंट में अगर n नंबर ऑफ डेटा पॉइंट्स हैं एक्सपेरिमेंट में, तो मीन होता है x बार विच इज इक्वल टू 1/n सिग्मा j इज इक्वल टू 1 to n xj. इसे हम लिख सकते हैं 1/n x1 प्लस x2 प्लस x3 अप टू xn. सो ये मीन डिनोट करते हैं. अगर हमें स्टैंडर्ड डेविएशन चाहिए, सो स्टैंडर्ड डेविएशन जो कि डेविएशन हो गया है मीन से, सो वी डिनोट इट बाय s स्क्वायर. एंड फॉर्मूला इसका होता है s स्क्वायर इज इक्वल टू 1/n माइनस 1 x1 माइनस x बार स्क्वायर प्लस x2 माइनस x बार क्या है मीन, x बार स्क्वायर x2 x3 डेटा पॉइंट्स हैं अप टू xn माइनस x बार स्क्वायर. सो हम इसे लिख सकते हैं 1/n माइनस 1 सिग्मा j इज इक्वल टू 1 to n xj माइनस x बार होल स्क्वायर. सो मीन हम लिख सकते हैं सम ऑफ ऑल डेटा वैल्यूज, सम ऑफ ऑल डेटा वैल्यूज अपॉन नंबर ऑफ डेटा वैल्यूज. विच इज इक्वल टू x बार एंड सिग्मा x अपॉन n. जबकि ये डेटा जो है एक सीरीज में है, इंटरवल के फॉर्म में नहीं है. इसे हम अरिथमेटिक मीन भी कहते हैं. एंड जैसे कि बताया x1 प्लस x2 अप टू xn अपॉन n. अगर हम समेशन लें xi जो कि डेटा पॉइंट्स हैं, इन डेटा पॉइंट्स को जैसे कि हमने कहा सिग्मा xi से डिनोट करेंगे n. x1 i is taking values from 1 to n. So sigma xi माइनस x बार इज इक्वल टू, ये हमेशा 0 के इक्वल होता है. डिफरेंस बिटवीन द डेटा वैल्यूज एंड मीन, उसका अगर हम समेशन लेते हैं तो ये हमेशा 0 के इक्वल होता है. x बार जो है जहाँ की अरिथमेटिक मीन है, हम AMCB से डिनोट करते हैं. I is taking values from 1 to n. और मान लें if x1 बार एंड x2 बार ये दो अरिथमेटिक मीन्स हैं कोई 2 सेट्स ऑफ डेटा के. x1 बार एंड x2 बार, these are arithmetic means, 2 sets of data. एंड सपोज इसमें n1 एलिमेंट्स हैं, इसमें n2 एलिमेंट्स हैं. नंबर ऑफ एलिमेंट्स आर n1 एंड हियर नंबर ऑफ एलिमेंट्स आर n2. देन अगर हमें मीन निकालना है उस केस में x बार होगा n1 x1 बार प्लस n2 x2 बार अपॉन n1 प्लस n2. सो कुछ फॉर्मूलाज हैं जो कि यूज होंगे. ज्योमेट्रिक मीन, मीन भी कई तरह के होते हैं, ज्योमेट्रिक मीन, हार्मोनिक मीन. सो वी विल बी डूइंग, दोज आर इम्पोर्टेंट. इसे हम GM से डिनोट करते हैं. सो मान लीजिए दो नंबर हैं, टू नंबर्स आर देयर ए एंड बी, सो इनका ज्योमेट्रिक मीन होगा अंडर रूट ए बी, और वी कैन से ए बी टू द पावर हाफ, मल्टीप्लीकेशन ऑफ ए एंड बी एंड power. Suppose n numbers are there, so geometric mean of n numbers will be a1 a2, these are the numbers a, and so we will multiply them to the power 1 upon n. Harmonic mean we denote it by hm, and this is if n number of data points, and we can write hm is n upon summation of I is equal to 1 to n 1 upon ai. तो मान लीजिए फॉर टू नंबर्स ए एंड बी नंबर्स हैं, ए एंड बी, हार्मोनिक मीन होगा 2 upon 1 upon a plus 1 upon b, summation of, so 1 upon a plus 1 upon b, जिसे हम सिंप्लीफाई करें, एलसीएम लेंगे डिनोमिनेटर में ए बी, सो दैट विल कम इन न्यूमरेटर 2ab, एंड व्हेन एलसीएम लिया तो ये b प्लस a होगा, जिसे हम a प्लस b लिख सकते हैं. एंड वी नो दैट इम्पॉर्टेंट रूल, AM is arithmetic mean is greater than equal to geometric mean is greater than equal to harmonic mean. अभी तक ये जो डेटा था ये अनग्रुप्ड डेटा था, और तब हमने मीन निकाला जिसकी की वैल्यू ये है अनग्रुप्ड डेटा, विच वी कैन राइट एज x बार. सो फॉर अनग्रुप्ड डेटा, now suppose group data is there, तब हमें निकालना है मीन ऑफ ग्रुप डेटा. अगर ऑब्जर्व्ड वैल्यू x1 x2 xn है, और जब हमने ग्रुपिंग की तो ग्रुपिंग में जैसे हम कहें कि x1 की 5 वैल्यूज हैं, इसकी 7 है, इसकी 15 है, से वी आर सेइंग से, सो हम इन्हें फ्रिक्वेंसी से डिनोट करते हैं. फ्रिक्वेंसी हम इसे लिख सकते हैं f1 मीन्स f1 इज इक्वल टू 5, f2, सो फ्रिक्वेंसी को डिनोट कर सकते हैं f1 f2, fn मीन्स x1 के 5 वैल्यूज हैं, 5 डेटा पॉइंट्स हैं, x2 7 टाइम्स अकर हो रहा है, सो वी हैव फ्रिक्वेंसी. देन मीन विल बी x बार f1 x1 प्लस f2 x2 अप टू fn xn अपॉन f1 प्लस f2 प्लस fn. फ्रिक्वेंसी को ऐड कर देंगे, इसे शॉर्ट में लिख सकते हैं, दिस सिंबल इज सिग्मा, सिग्मा जो कि समेशन के लिए होता है i इज इक्वल टू 1 टू n fi xi, सिग्मा इज दिस इज सिग्मा अपॉन होल अपॉन सिग्मा i इज इक्वल टू 1 टू n fi. Now mean, so we write it again, sigma I is equal to 1 to n fi xi upon sigma I is equal to 1 to n fi. Assumed mean method. X bar is equal to a plus sigma fi di upon sigma fi. We can say a plus d bar. So d bar is equal to x bar minus a. Equation को simplify किया. So we can write x bar is sigma fi xi upon sigma fi minus sigma fi into a upon sigma fi. So this is sigma fi, दोनों को कंबाइन कर लिया, xi माइनस a अपॉन सिग्मा fi. So we can write down sigma fi di. अपॉन सिग्मा एफ आई। सो ये फॉर्मूला हो गया डी बार के लिए। सो वी डू वन एग्जाम्पल बेस्ड ऑन class interval or grouped data and assumed mean. So age group is given. We call it class interval. Then number of people in each class interval, and then we have to this much given in the question: 10 to 25, 25 to 40, 40 to 55, 55 to 70, and 70 to 85, 85 to 100. And number of people in class intervals 3, 11, 10, 8, 6 and 2. So this much have been given in the question, and we have to find out the mean. So we may apply sigma fi into xi, sigma fi xi upon sigma fi, but we will be using the assumed mean. So first we make class mark. Class mark is midpoint of the interval. So average of these two, 35, 10 plus 25, 35 upon 2 is 17.5. Then 40 plus 25 is 65 by 2 is 32 by 2. So add the values of the interval and divide it by 2, you get the values: 47.5, 62.5, 77.5 and 92.5. So this is class mark. Now we find out di. Di is deviation, which is xi minus a. There we wrote d bar is equal to x bar minus a, same thing. So in I means for various values. We assume that assumed mean is 47.5. We generally take roughly in between value, but if you take any value then also it gives correct answer. This I have checked, but in between we take, it is easy to calculate. So corresponding to this, because we are writing xi a, we have written capital A. So this is 0. This we are saying xi, and a is this value. So when we subtract here 32.5 minus 47.5, it comes minus 15. 17.5 minus 47.5 is minus 30. Here 62.5 minus 47.5 is 15, and then this gives 30 and 45. So now we have di. We calculate fi di. It comes minus, this is fi, number of people. Fi di, these are di's. So corresponding value we calculate, multiply 3 this value into this value, then corresponding values, this value by this. So 3 into 30 minus 90, 11 into 15 minus 165, then 0, then we multiply 8 into 15, 120, then 30 into 6, 180, and then 90, 45 into 2. So we add them, this comes 135, which we say sigma fi di is equal to 135, and we add sigma fi also, it comes 40. So formula for mean is x bar is equal to a plus sigma fi di upon sigma fi. So we calculate 47.5, which is a, plus 135 upon 40, this value upon this value. and A is this value. We get 50.875. So we did now for group data, for ungrouped data, by taking class mark. Class mark may be in decimals, it may be round number also. Then we took assumed mean here, and with the help of assumed mean we calculated the mean. Median we did in the case of range, when we calculated range and interquartile range. We did for ungrouped data. So for group data we need formula, and when numbers are arranged either in ascending or descending order, median is the middle term. When number of terms is odd, it means what will be the median? Odd. N is odd. Suppose N is odd, then we will have value of n plus 1 by 2th term will be the median. And when n is even, then average of middle two terms means 1 by 2 of value of n by 2th term plus value of n by 2 plus 1th term. So we took the average of this. Say n is equal to 16, so this will be 8, and 8 plus 1 9th. So summation of these terms, 8th term plus and average of these two, n by 2 plus 1 is 9th term. And when n is odd, say n is 15, then it will be n plus 1 by 2 means 16 by 2 means 8th term. Suppose we have terms 5, 15, 25, 35, 65 and 75. These are the terms we have. So 1, 2, 3, 4, 5, 6 terms are there. So n is even. So it will be 3, 3rd and 4th plus average means 25 plus 35 by 2. So the median will be 30. This was for ungrouped data. Now we do for grouped data. So group data we will use the formula. Data is given in groups. So median will be L. L will be lower class of median class plus n by 2. N is number of observation minus CF. CF is cumulative frequency of class preceding the median class upon F. F is the frequency of median class into H. H is class size. So L is lower limit of median class. So we have to find out median class. We'll do one example and see how to find out median class. N is number of observations. Then CF is cumulative frequency. This also we'll see how to find cumulative frequency in the example. Of class preceding the median class. Then F is frequency of median class. And H is class size. So we see the example and solve this. Here we have number of rooms in hotels. Example, number of rooms in 50 hotels. Class interval, frequency, and cumulative frequency. So this data will be given to you. Class interval, which is less than 140, means in the hotel less than 140 rooms are there. 140 to 145. Then 145 to 150, and 150 to 155, 155 to 160, 160 to 165. This is class interval which is given in the question, and frequency is 4, 6 for this. These are corresponding, means less than 140 means 4 hotels are there, and between 140 and 145 rooms are there, then 6 hotels are there, 20, and here 5, 13 and 2. So this is given in the question. In language it may be given. You have to write the data. Now we want to find out cumulative frequency 4. Then add next frequency. 4 plus 6 is 10. Then add next 10 plus 20 is 30. Then 5 plus 30 is 35. 35 plus 13 is 48. And 48 plus 2 is 50. So this is cumulative frequency. Now we have to find the median number of rooms. So median is, as it says, L. L is the frequency of median class. So how to find out median class? Here N is 50. So 50 by 2 is, N by 2 is 25, which lies in, we will see cumulative frequency, which is 30. So which lies in this interval. It is called median class, and range for this is 145 to 150. So L will be 145. So 145, lower limit of this median class. This is median class. Plus N by 2 is 25, which we have calculated, minus previous frequency, previous cumulative frequency, which is this one, 10 upon F. F is frequency of the median class, which is 20, into the class interval. Class interval is difference between the upper limit and lower limit, because it is same 5. So generally we will be doing of same size intervals. If it is different, then the situation is different, but mostly we do with the same interval. So we solve it. It comes 145 plus 15 upon 4. So we calculate it. 145 plus 3 and 7, because 12, then 3, 28, 7, then 5, 2, 20. So this becomes 148.75. This is the median. Now we do mode for group data, because in this we have done now median for ungrouped as well as group data. Now we do mode. Formula for mode of group data. For ungrouped data, whatever values comes many times, that is called mode. Suppose in a series 10 is coming many times, so 10 will be the mode of that data, the number which occurs maximum number of times, group data. So this is equal to L plus F1 minus F0 upon 2F1 minus F0 minus F2 into H. Here L is lower limit of modal class, then it means class with maximum frequency in modal class. We'll do one example and see. H is size of the interval, F0 is frequency of the class preceding to the modal class, then F1 frequency of modal class, F2 is frequency of class succeeding to the modal class. So we do one example. Number of cars in lakhs on the road of 30 different states have been given. So cars interval, cars intervals in lakhs is 1 to 3, 3 to 5, means 1 lakh to 3 lakh cars are there, 3 to 5 in 30 states on road, 5 to 7, 7 to 9, 9 to 11, and number of states for this it is 10, then 8, then 5, 6 and 1. What is the mode of the data shown here? So modal class is the maximum frequency. This is modal class. L is 1, lower limit of modal class. F1 is 10, the frequency of this. F2 is 0, there is no frequency before that. F0 is 0, F0 is 0, there is no frequency before that. 8, H is 2. So we substitute the values 1 plus F1 minus F0, 2F1 minus F0 minus F2 into H plus L. F1 is 10 minus 0 upon 20 minus 0 minus 8 into 2. this comes 1 plus 10 upon 20 means 5 upon 6 into 2, so this is 3, so this comes 8 upon 3, which is 2.66 approx. So in this manner we can find out mode of group data. For ungrouped, as I said, the number which occurs maximum number of times. It may be the situation that mode does not exist in the data. Next we find out empirical relationship between mean, median and mode. Like this, we generally take normal curve like this, and it may be the situation that it is skewed and this has shifted towards this. Similarly, the peak may be here somewhere, then figure will shift to this place. So if it is skewed, maximum data in this curve lies here. So in this case, so this is moderately skewed distribution. So mode is equal to 3 of median, 3 multiplied median minus twice of mean, means 3 median minus 2 of mean. Mode is equal to, skewness tells a degree of departure from the normal. Let's see one example. Here mean is given 39, mode is 36. We have to find the median. So median will be, mode is equal to 3 median minus twice mean. So mode plus 3 median is equal to mode plus 2 mean. 36 plus 2 into 39, it comes upon 3. This is 114 upon 3. So this is 38. Now let's write standard deviation formula, which we say S square is equal to 1 upon n minus 1 x1 minus x bar whole square plus x2 minus x bar whole square up to xn minus x bar whole square. So it may come and it can be written 1 upon n minus 1 sigma j is equal to 1 to n xj minus x bar whole square. Now we will be doing union and intersection formula as well as permutation and combination. So I will just write a few formulas. Suppose one sample space is there and sample space is S, denoted by S, and A and B are events, and suppose C, whenever we require we will use ABC as events. So we know that we have to remember these formulas: A intersection A complement. Complement we know how to find out in the graph, that suppose this is sample space and this is the A, then A complement is this is A complement. So A intersection A complement, nothing is there. If we subtract from S value of A, we get complement of A. So there is nothing common. It means it is equal to phi. Phi is null set. No value is there. And we say A complement of complement. Then this becomes A. This portion. And sample space complement is phi. And phi's complement is S. और अगर हम यूनियन ले लें ए यूनियन ए कॉम्प्लीमेंट तो वो सैंपल स्पेस के इक्वल हो गया. डी मॉर्गन्स लॉ कहता है, डी मॉर्गन्स लॉ, दैट ए यूनियन बी, बी अब इवेंट है एंड कॉम्प्लीमेंट ऑफ दिस विल बी ए कॉम्प्लीमेंट इंटरसेक्शन बी कॉम्प्लीमेंट. एंड यूनियन एंड इंटरसेक्शन आपको पता है, दिस इज यूनियन एंड दिस इज इंटरसेक्शन. एंड अगर मान लीजिए एक ये सेट है और दूसरा सेट ये है, तो ए यूनियन बी में ये सारी वैल्यूज होंगी जो इस सर्कल और रेक्टेंगल में आ रही है. लेकिन इंटरसेक्ट करना हो तो सिर्फ ये पोर्शन which is completely filled here is intersection. So suppose this is A and this is B. The circle is B, A is rectangle. So A union B is the full. A union B, all elements of A and B. And A intersection B is common in AB. Common elements in A and B. So De Morgan law says A union B complementary is A complementary, intersection B complementary. And for intersection also it says A intersection B complement is equal to A complement union B complement. So this is De Morgan's law, these two. Now suppose we have A union B intersection C. So this becomes A union B intersection A union C. ये when डायग्राम में आपको काम आए. So these will be used there. And A intersection, a few we are remembering which are important. So this will help us in solving the questions. A intersection B union, and after this intersection union formulas we will be doing permutation and combination. Union A intersection C. So statistics part is over. For Venn diagram also we have written the formulas. Now we write definition of probability. In the sample space S, just now we showed that we can show sample space. Sample space is, if we have done one experiment, all the outcomes of that experiment will make a sample space. If the sample space of an experiment consists of finitely many outcomes that are equally likely. This is important point, because अगर वो equally likely नहीं होंगे तो this definition won't work. The probability of A of event A, we denote it by PA, of an event A denoted by PA is equal to number of points in A, that is the event A, upon number of points in sample space S, and PS is equal to 1. We define it in another way also. Number of favorable outcomes upon number of total experiments. Number of times A occur and number of total trials, that also we will discuss. So PS is 1. Now we do one example. We write it in another way also, which is, we call it relative frequency. So f of relative frequency A, which is PA, which is FA upon N, means number of times A occur upon number of trials, or we say number of favorable outcomes to A upon number of total trials. And relative frequency also, this 0 less than equal to F relative A is less than equal to 1. Example, enrolling a fair die once. What is the probability of A obtaining 5 or 6? So they, as I said, die 6 sides are there and we are rolling it 5 or 6. So 2 favorable outcomes are there and total number outcomes are 6. So it is 2 upon 6, which is 1 upon 3. So this is the probability. For this we can write also 0 less than equal to PA, probability of an event is less than equal to 1. Same thing. So till now we saw probability axioms we can mark. Suppose we have a sample space S and one event A is associated with this S and A is subset of S. Then there is associated number PA called the probability of A if it satisfies the following axioms, that for every A, 2 we have already written here, in S we have this, that probability of A lies between 0 and 1. It won't be negative, it won't be more than 1, so it lies between 0 and 1. And for entire sample space S, entire sample space S probability is 1, maximum it can be 1. Third, if events are mutually exclusive, suppose A and B, 2 events are there and they have the probability PA and PB, so PA union B will be equal to PA plus PB, mutually exclusive when they are there, otherwise the formula will be different. And suppose and A intersection B is equal to 5, there is nothing common in A and B. Suppose we have n number of points which are mutually exclusive, then we can extend this formula, and that rule is called addition rule for mutually exclusive events, and we can write the formula P of A union A1 union A2 union A3 up to AN events are there. So this will be equal to PA1 plus PA2 up to PAN, addition of all probabilities. So we say it addition rule for mutually exclusive events. Nothing is common in the events, between the events. Now basic theorem of probability. Suppose an event A is there and its complement AC in a sample space S. Then we can write P of AC is equal to 1 minus PA, and we write 1 is equal to PA plus PA complement, and this is equal to PS. S is equal to A union AC, A union A complement, and this also I have told A intersection AC is fine, nothing is common between these two, and the figure is, this is sample space and then A is there, so the remaining part, this one which has been dashed, is A complement. So S minus A is A complement, roughly we can say. Addition rule for mutually exclusive we have already done. So addition rule for arbitrary events. Mutually exclusive already done. Arbitrary events, so sample space is S and events are A1, A2, AN. Then this will be so we take for two events, it becomes PA union B is equal to PA plus PB minus PA intersection B. We can extend it for 3 also, and P of phi is equal to 0. This also we should remember. Null set probability is 0. There is no event, then probability is 0. Conditional probability. Suppose A event has been completed, A is already completed, then probability of B when A is already happened, A happened, then this is PA intersection B upon PA. So here whatever is in slash happened is in denominator, so we can write P AB means B already happened, then probability of happening A is PA intersection B upon PB. Now multiplication rule says if there are two events PA and PB and PA is not 0, it is given PB is not 0, and same here also, PB is not 0 and PA is not equal to 0, provided that this rule is when अगर डिनोमिनेटर में 0 हो जाएगा तो ये इन्फिनिटी हो जाएगी, which is not valid. So denominator should not be 0 in these cases. Here also we are taking PA and PB are not equal to 0. Then multiplication rule says PA intersection B is equal to PA PB upon A. This we can find out with the help of cross multiplication also. This we have cross multiplied, and similarly from here we can find out which is PB PA/B. And if two events are independent, then we can write down two events are independent, say A and B are independent events, then PA intersection B is equal to PA/PB. Then we can write from the above formula which we have written just now, PA intersection B is PA/PB, and which is equal to PA/PB upon A, and which is equal to PB/PA upon B. So we cancel out, when we take these two we can cancel out this. So PB is equal to PB upon A, and PA is equal to, from this one, PA upon B. Now we write one more formula where we write addition of means the mean we call it expectation also. The mean we call it expectation also of a sum of random variables equals the sum of the means expectations, that is E. Expectation we write by E, x1 plus x2 plus x3 and so on is equal to EX1 plus EX2 and up to EXN. So mean, this is, we are doing the addition of means. And multiplication of means will be we multiply here independent random variables so we are taking mean or expectation of the product of independent variables is equal to the product of means, that is E of x1 x2 up to xn is equal to EX1 into EX2 up to EXN. Similarly, we can say addition of variance. So we will add the variances of those variables. That also can be done, addition of variables. Now we write formulas for permutation and combination. So we are doing permutation. So permutation of given things may be elements or objects. This is what is an arrangement of these things in a row in some order. For example, if we take three elements, three letters A, B, C, these are elements also, then the permutation will be factorial 3, because if you want to write these numbers together, then first place will be having 3 choices. Out of A, B, C we can put any number here. Then remaining 2 numbers will be having 2 choices, and then last is 1 choice. So this is one combination. So here we can take B also, or we can take C. Once we have taken this, the number next will be according to that. So 3 choices at first place, at second place 2 choices, and third place 1. So total number is 6. So factorial 3 is 6. Factorial n is basically n into n minus 1 into n minus 2 up to 3, 2, 1. We write like this. Or we can say 1, 2, 3, reverse order, n minus 1, n minus 2 and n. In short we write 1, 2, 3 up to n. This is called factorial n. Any form you can think of. This is much common. Now permutation, when first case, when we are taking different things. In this case permutation will be factorial n, which is 1, 2, 3 up to n. And second is when we are taking classes of equal things. So this is n things are there, and they are being divided into C classes. C classes of alike things. Means कुछ चीज़ें एक सी हैं. So that is number 1 class. Then we take another set of things which are same. That will be second class. So C classes are there. In this case, number of permutation of these things taken all at a time will be factorial n upon n1 factorial, n2 factorial up to nc factorial, and n1 plus n2 plus nc is equal to n, total number of items. And if we write in general, nj means nj is the number of things which are in jth class. Now here we had taken all the things at a time, but if we take k different things at a time, third, the number of different permutations of n different things taken k at a time. In the above we took all at a time, k at a time, without repetition is n into n minus 1 into n minus 2 up to n minus k plus 1, which comes factorial n upon n minus k factorial. So this formula, if you write, simplify, this comes this. After this, the term will be n minus k factorial, which will cancels out with this, and with repetition it will be n to the power k. Now we do combinations. So we are taking n different things, and the number of combinations of n different things taken k at a time without repetition is nk, means nck. We had read this formula, n factorial upon r factorial n minus r factorial. So this will be factorial n factorial k factorial n minus k. So this can be written n into n minus 1, n minus 2 up to n minus k minus 1 will be k plus 1 into n minus k factorial upon k factorial n minus k factorial. This will cancel out. So this is n into n minus 1, n minus 2 up to n minus k plus 1 upon factorial k is 1, 2, 3 up to k. Now we take number of different combinations with repetition, the same thing, and different things are there. With repetition it will become n plus k minus 1 k, which is n plus k minus 1 ck, and we will apply this is n in NCR. Here n is n plus k minus 1. So we can apply the formula and get the result. And we should know factorial 0 is 1 and n plus 1 factorial is n plus 1 into n factorial. Now we will be, thank you.